Hello, welcome to CESMII Studios in our broadcast of 6 Degrees of Smart Manufacturing. I am Conrad Leva.
And I'm Mike Yost.
And in this series, we cover different perspectives and topics on smart manufacturing from the many points of views of business leaders, practitioners, integrators, consultants, engineers, and educators. And today with us, we have a 20-minute chat with our guest, Joe Cuiffi from Penn State. You can ask us questions via the Q&A feature at Zoom. However, we might answer some of those questions later at our LinkedIn group. We will give you that link at the end of the show.
Yes, and also, we want to jump right in, and all the recordings are also on our YouTube channel. We'll give that information again at the end of the show. But quickly, just to give a little bit of background on why we talk about 6 degrees of smart manufacturing, it's based on the concept that we are all just 6 degrees of separation from knowing every person on the planet. And when we try to tackle the question of how do we make smart manufacturing a reality, we believe that the more interaction we can have with the people who are in this space, the more we can learn with and from each other. So that's what this is about, a quick 20-minute chat with as many people with as many different perspectives as possible, as Conrad already mentioned. And so with that, we want to welcome our guest here today. It's Dr. Joe Cuiffi. He's the program coordinator of the electromechanical engineering technology at Penn State, New Kensington. Joe, like me, is an engineering grad from Penn State. However, unlike me, Joe graduated with honors and got a PhD from Penn State. So Joe has a great balance of academic experience as well as industry experience, having co-founded a company and built production facilities. Spent a good bit of time in industry, and he's a good partner of CESMII's. So Joe, we welcome you here with us today on our webcast.
Thank you. It's great to be here.
And Joe, we want to start today with this question for you. We want to know, what does smart manufacturing look like from the perspective of an engineering professor trying to teach on the subject?
Yep.
Yeah, and it's a tough one. There's a lot embedded in smart manufacturing. It's a very complicated topic, so it's challenging for us, but that's why we're here.
And I know you'd like to start your course grounding it on the smart manufacturing concept and an introduction and talk about the definitions. So I would like to ask you, how do you start your course and do that setup for your students?
And I do like to set it up with definitions of smart manufacturing, and really the purpose of the course and the purpose of my teaching is to make aware and empower some of the students. You know, this is a culmination of a lot of very complicated technologies, and you know, at the upper end of the automation pyramid, and it's a lot for undergraduate students to take in. But my goal is to give them awareness of what's possible. So, hey, this is what smart manufacturing is and can look like. And then tinker with some things and teach them as much depth as we can to then empower them when they go out into their, field of work and say, hey, I've seen this before, perhaps we can do this. So really it's about awareness and empowerment, but we got to start with just showing them what it is, which are a lot of the pieces that you show here.
Yeah, and we've gone ahead and highlighted here some of the things that you specifically cover in your course. Just to stress the point that no one course, unless it's very high level,
Right.
can cover the whole spectrum of smart manufacturing, but then you have to start drilling down into different areas.
Absolutely.
So, obviously, from what you just said, Joe, that aligns very nicely with CESMII's charter, right? We're trying to do work through folks like yourselves to educate a very broad, very diverse ecosystem. So tell us from your perspective how CESMII is helping you. Like, where do we fit in this equation?
Well, what was great for us was early on when I came to this campus actually and started meeting with our chancellor, and we were meeting with the community, we had started hearing a lot about, hey, we're getting a lot of questions about Industry 4.0 and smart manufacturing, or my customer has been asking me for digital twins. I don't even know what that is. Are you guys teaching your students this? And we had these discussions, and almost immediately we saw the CESMII RFP announcement and started working with this group when they emerged. And it just fit in perfectly with our timing and what we were trying to do. I was trying to develop a smart manufacturing course. So for us, getting involved with CESMII and then kicking off this project, Factory 4.0 Toolkit, was just pivotal and perfect timing for us. So.
And what do you mean by digital twin? Is that like Mike and I, two wild and crazy guys over here?
Yes, right. We're twinning. We're twinning. Got the headsets, got the glasses. Come on.
Yeah, so I verbalized digital twinning on this slide, but you know what we did for this project, we partnered with MIT, and Brian Anthony's group had developed this small classroom extrusion device. It's a mock process, and we were overlaying these sort of 4 areas of smart manufacturing topics onto the training materials, and then using this tool and a digital twin of it, which is sort of a simulated representation of it, to cover these topics with students. So it was kind of our central hardware piece that we were to build a factory around. And yes, digital twinning was sort of one of those tasks.
Have you found, I mean, it took a lot of work to put this hardware kit together. You must have found that hands-on experience is very important in education. Can you tell us a little bit about that?
Absolutely. You know, we're a very hands-on engineering program. The EMET program is very similar to industrial engineering, but a little bit more hands-on. And so our students are very tactile, and they need to see how data shows up in their actual devices. So a lot of these early exercises with this tool are to get them to try something and then show it. Otherwise, you're left with a whole bunch of data analytics activities, which are very dry. It becomes a statistics course, but it really helps ground everything, and they can tinker with it. And even though we had to go over Zoom this past year, I had videos of the machine working in later lectures when we went remote, and it worked out pretty well.
Outstanding. So let's talk about the energy component, right? We talked about, we know that what you're doing there, part of the analytics, part of the sensoring, all that kind of stuff leads you toward being able to use this hardware and visualize the data, analyze the data, model the data, those sorts of things from an energy perspective. So could you walk us through that side of the
Sure.
education?
And this has actually come up in my prior educational activities I had done, where I was looking at energy monitoring of buildings, facilities, sub panels. And it's one of the quick things you can do to retrofit equipment is to put on sub metering or energy monitors. And so it's a key part of this. One of the things we did to this tool, which we called Fred, right away, is to put on current and power monitoring, and we can put it on 3 legs of the machine so we can see subsystems. And these are little chips where they're dirt cheap, you know, $10 for 3 or something. And we can sit there with students and wire them up and pull the data. And it doesn't have to be integrated in the control system. It's a true retrofit. You control the machine by PLC, but this is completely offline, develops its own sensor network. So, and you can have every student in the room deal with that. So it made a great activity to put these sensors on, and then it led us to being able to do different activities with that data that we wouldn't have gotten with the standard control system.
And one of the things I love you cover in your course is that you really get down to energy as an ingredient. And but how do you set up an exercise to look at different kinds of inputs and optimize the process?
And that's really the key. We try to walk them through. So first of all, it's, you know, you have to monitor it or you have no idea. So we get them on there, and then we have the data, and we pull it up, and we can pull it up all across the room on the little local network. And first things first would be something like the lower right. What's actually consuming the power in our process? Do we have any idea? Now, experienced manufacturing person would know it's the heater, but it turns out to be the heater, and it drives everything. And it shows you that, hey, that most of our energy is going into the heater. What can we do to help that? Can we insulate it? Whatever, what can we do? But then we can get more clever with it, and we can assign a dollar per energy use, and then how much fiber you're producing, and really start to get into the nitty gritty of how should we run this tool so that the cost is lowered, not just of the materials, but also the energy use. Does it make the product quality worse or less? Is there a sweet spot? And that's what we show in the upper right. Based on a ton of run conditions and historical data, we can take that energy, we know the cost that we buy our energy at, and we can actually optimize the operations of the system. You know, that becomes really key in areas where they have market cost energy, like in Texas, where you can buy it cheaper or more expensive at different times of the day. That can all factor into the logistics of your factory. So really having that involved in some of those calculations is a key sort of showcase of that, Conrad. And we try to end there, but we also show the smart monitor, which is in the middle. This is where we have a digital twin of the system running. And historically, we know how much current the motor should draw at any different operating condition. And if it deviates from that, it alarms. So it's a smart monitor. It actually monitors the energy consumption. So that's a lot. There's a lot in that, but that's what we try to walk them through.
So how we talked about the point of view from the professor trying to teach these things. How has the reception been from the students, and the point of view about the students, or maybe the different kinds of students you've run through this program so far?
Yeah, and that's a really good question. I brought this up earlier when we were talking, but the students, it's an interesting thing. They have grown up in an age where they can pull up the data from their bank accounts on smartphones. They can look at their Fitbit and track their blood pressure. But yet we go into a factory, and this happened when I came here. We're running Windows XP on a computer, and I have a floppy disk with G code that I'm moving from computer to computer. So it's almost shocking to them. And they love to see when we have information that's much more accessible and we can look at things in this networked way. However, I will say that when we get then down into the depth of how we make that all work, it's a lot for them to take in, as with anybody, even manufacturers. It's just a lot. You know what's possible because you see it in your life, but then to implement it takes a lot of work.
Yeah, that's what I was going to ask. I'm curious about that. Exactly the point that you said. Sort of two dimensions there. One, students signed up to take is this officially labeled as a smart manufacturing course?
This one is now, yes.
All right. So do they know this is smart manufacturing, or I guess?
No, they just know me and figure I'll just take that course.
But I think it's a great point of, well, isn't this the way it's supposed to be? Wouldn't we expect coming into a domain that we could get the information that we need and things like that? So have you seen that as a stumbling point, or just and maybe the age of your students, right? So are they second year, third year, fourth year engineering students? They have a little bit of experience already from an engineering.
Yeah, this really culminates. This is actually final semester senior year, so we can tie it all together. And you know, like I said, they do come in and they know about technology and they know the parts and pieces. They love to see it all work together. And I think they think that manufacturing is smarter than it is sometimes, and they get a little bit of a shock when they go to their internships. But hopefully we can help them, you know, modernize companies as they move on where they see fit.
Well, that's interesting. Do you think we're crossing a point here where manufacturing is starting to become cool again, or is there still that reality of Windows 3 on the factory floor and things like that? I mean.
Well, I think manufacturing's cool, but yes, no, I think so.
I meant with your students. Obviously, we think it's cool.
Very cool.
I mean, I think that whether companies resist or have trouble integrating their data and upgrading every new piece of equipment, even new robotic arms, all that, it's coming with all these tools. So it's slowly being worked in, and I think to much excitement of the workers out there. They just need it to be easier so that they can get started. But it brings up much more that you can do. So it gets difficult to integrate in all your data, but the machines being sold and the vendors that are out there, it's all pushing towards more data, more integration of data.
Are they signing up because smart manufacturing is cool, or because Professor Cuiffi is cool?
It's cool.
I don't know. I would hate to see the answer to that, perhaps.
Yeah. And I've heard you say that Python is the new Excel, at least when it comes to statistics. So, is
That's
that a
personal-
follow-up course or something, a prerequisite, or what?
That's a personal mission of mine to basically, engineers are so good with Excel and it's such a powerful tool for us. But when we're collecting all of this data, it becomes a mess. And I have a little mission to switch people over to MATLAB and Python and these more statistically based scripting languages to go through the data. And I have a personal mission about that, and I do like using Python, and I do show it to my students.
Well, again, difference between my Penn State education and yours. I would run away from a Python if I saw one. So I'm not getting deep into that. But this point about how cool, I'm not going to get into the point about how cool you are or are not, Joe. But how cool manufacturing is or is not is something that obviously we're dealing with and facing as a broader than one engineering program or one engineering class. But we've had some other conversations in this series talking about the difference between like the U.S. education and the European education, and like the Industry 4 in Germany and things like that is really focused postgraduate, right? And so the fact that we're teaching this now as an undergraduate level program, and we're seeing more of that across the country, and we're starting to push these concepts down. I think it's, I guess, indicative of what we're trying to accomplish here from a CESMII perspective, as far as the democratization and making it more easily understandable and accessible. And so I guess from your perspective, do you see us, I guess, continuing to push this down to where this becomes more about, this is just the way manufacturing works, because all of my systems are either coming in smart already, or it's easy enough for me to retrofit and things like that.
Well, I think, it's all about competitiveness and making our manufacturing base competitive. And I think we have to make our students aware. We have to make the current workforce aware. And so starting them in as the undergrad, it has to become a component of some of these manufacturing focused programs. You have to show them what's possible and teach them where to go next. Where can I continue to learn? How can I make my facility better, knowing the tools that I have? I may not have picked up Python as an undergraduate to do data analytics, but I saw a crazy professor do it in class once, and I'm pretty sure it can help us with an energy optimization problem on our manufacturing floor. What can we do? So for me, in the American style, we're encouraging folks to continue to learn. We're not, it's harder to force if we're not, having manufacturing graduate students, which is not the most popular thing in this country, but we have to force engineers and our future workforce to think about this stuff.
Excellent. Well, guys, we are just about up. Conrad, is there any last questions that you want to throw at Dr. Cuiffi here before we go to close?
No, I think this is a good point to close. We'll let Joe finish this off here. So Joe, how we started with this question, and we want to now give you a chance to close up. What are the big takeaways that our audience should have here about teaching engineers, about teaching smart manufacturing?
The first is we really have to work as a community to show the possibilities of smart manufacturing to students and current workforce, so that they can see what's possible and continue to learn to take advantage of all the new tools that are out there. And there are many. And the second takeaway is that something like energy monitoring can be a simple retrofit. We can use it in classes to demonstrate, but you can also use it in your facilities to look at energy and really take a deep dive into costs for yourself. So those are my key takeaways. So thanks for having me and letting me discuss that.
Excellent. Well, we certainly appreciate your time. And as we said at the beginning, these conversations are part of what we're trying to drive for the benefit of our broader community. We will post the recording of this session onto our website and onto our YouTube channel. We will also post links to it from our LinkedIn group. So I'd encourage anybody who's watching to watch this, share it with others, ask questions within our LinkedIn group. So we can continue the discussions and get input from others. Your voice is important as well.
Yeah, and stay tuned for our upcoming episodes. Because of the holiday season, we only have one in November and one in December, as opposed to our usual 2. But we will have a very exciting show coming up with a retrospective of the highlights of smart manufacturing in 2020. It's been an exciting year, and this will be an exciting show. And we're going to also talk about how throughout many of these episodes, throughout a lot of the interactions with the CESMII leadership team, all the members that participate in that ecosystem, we have converged on the an updated smart manufacturing definition, which you saw a preview at this show. And but we'll get a little more specific about that. But really, how all that input has led us to put an update up there of smart manufacturing definition and get more specific about the expectations and that vision. So that's very interesting. And we'll close the year with a show on the hot trends that we're going to be following next year, and the surprises that might be around the corner for smart manufacturing.
Yes. So thank you again, Dr. Cuiffi. Thank you, Conrad. And thank you, everybody, for joining us. And have yourselves a wonderful day. Take care. Bye-bye.
Thank you, guys.